Okay, so for the bottom part of the triangle, born from me splitting this triangle, I'm going to suggest that that is opposite the angle, wherein this angle we've decided to call theta as written below. So this is our theta. This is the bottom of this angle here, opposite is there, and the long side here is hypotenuse, leaving you with sine theta is opposite divided by hypotenuse. Now, what we can do from that is we can do a little bit of algebra. If I multiply both sides by h, so for example, I times by h on this side, and then I times by h on this side, very elaborate x times by sine there, you would come across h sine theta equals opposite. Now, h sine theta is opposite is useful for this bottom part, but for the top triangle here, we will probably want to use, let's say that that's the angle in there. That's the angle I'm interested in, and I'm going to call this, we've already discussed this one will be A. So for this one, we have sine A, well, sine A is slightly different. Sine A is going to be opposite, so still opposite, but divide by h2 this time, divide by h2. So there's your h2 over there that we are dividing by. Again, if I multiply both sides by h2, I get h2 sine A equals O. They are both equal to O. That is what is fundamental here. This equals O. I don't really want an arrow for that, like add to confusion more than anything else. That equals O, and so h sine theta equals O there, but also h2 sine A equals O. And that makes sense in terms of logical thinking. I drew one line, so this triangle's bottom part is equal to this triangle's top part. They are both equal. So when I have a situation where I am comparing h sine theta and h2 sine A, they are both equal to opposite. That side and this side are opposite. So I'm straining that because once you know they are equal, then we can make this equal as well. We can say, well, h sine theta, that's what I mean by this, is equal to h2 sine A. And we get a lovely little rule that we can call sine rule. And normally in textbooks, you could divide both sides. You can divide the right hand, both sides by sine theta, and divide both sides by sine A, so they look like fractions. But overall, this is the concept. The concept is when you have a triangle, you can split it in two. You have two right angle triangles. You can then use trigonometry to end up with sine theta equals opposite over hypotenuse for that random rectangle. Looks strange now. It should have been an arrow. I think it changed later. Sine theta equals opposite over hypotenuse for the bottom. And depending on how you label it, sine A is equal to opposite over the hypotenuse of the other side for the top part of the triangle. And because they both equal opposite, you can make them equal. And this can be used to solve problems, as I will do later. But I chose to split it there because it is an easy thing to visualize. We can find other places in which we can split it